This is logic coding. This is yet another linked list problem. I've been doing a lot of linked list problem. It's one of my weakness. But anyway, so within that, we're given the head of a singular linked list and return true if it's a palindrome. So we have a linked list and we want to determine whether we want to return a Boolean value to indicate whether it's a palindrome in terms of its value. So for example, 1, 2, 2, 1. If we going from backward, we have 1, 2, 2, 1 as well. So it returns true because this linked list is a palindrome. The second example is 1 and 2. If we do it in reverse, it's going to be 2 and 1. And it's not a palindrome. And the follow-up is, could you do this in constant time, basically linear traversal, or in linear time and constant space? Okay, cool. So how are we going to do this? So for a palindrome, we normally just compare, if it's array, we compare the value. But if it's a linked list, we actually need to reverse the second half of the linked list and then compare the value one by one. Because we don't have access to the last node, the link is given by a pointer. So what we will do is we first find the second half of the linked list, we reverse it, and we compare the node one by one. So divide the linked list into two parts, reverse the second half, then traverse two linked lists, compare values, and if at the end if differs, return false, right? Okay, cool. So basically then time complexity will be O(n), and the space complexity will just be O(1). So how are we going to do those three steps? So first, we want to divide the linked list into two parts. So what we can do is we can have a fast pointer and a slow pointer, where fast pointer moves 2 steps and then slow pointer moves to 1 step. So if it's odd number, so if I have 1, 2, 2, 1, 2, if my fast is here, first I move to here and then I move to here, so 2 steps, then my slow pointer is going to be at 2. If I have even numbers, I want my slow pointer points to this one. So for the fast, I want my point to point this one. For the slow, I want points to this one. Then what I can do is I can use a fast and slow pointer to find the middle point. Actually, we want the previous point. So what we can do is, so within, I know I want to do fast equals to 2 step, and slow is just 1 step. So here, what I want to do is I actually want to do not fast, while fast next has value, and fast next also have value. So for example, for the even one, I want my fast first go to here and then stop, because then my slow will be here. So in this way, then my slow next can just equal to reverse list slow next. Yes, and then I forgot to declare my fast and slow pointers. So I have list node, fast start from head, slow also start from head. And then afterwards, let me declare another node start. And then what I need to do is let me move my slope pointer to its next, since I want to compare my slope here and my start here. So after reverse, this will become 1 and 2. Then I just compare 1 by 1. So while my slope still have value, if my start value is not equal to my slope value, then I know it's not going to be a palindrome. Otherwise, I move my start 1 step forward, and I move my slope 1 step forward as well. Okay, cool. Now what I need to do is I need to define this reverse linked list. Okay, this node reverse list. So we're given a list head. This is a classical routine to reverse the list. We declare a running node called current equals to head, and while my current has value, then I do first, let me get next node, because I want to keep record of what's next, and then I make my current next points to the previous, make my previous equals to current, my current equals to next, and then at the last I just need to return my the last node, return proof. Let's try and run the code. Forgot. Submit it. Cool. Why it's so slow? Yeah, never mind. So this algorithm will be all linear in time and constant in space, since we're just using those pointers and rewiring those pointers. I would say some important thing is when you find the middle point, you need to be careful of when is the exact middle point, when you want a point before or when you want a point after. And this is also a careful step. After you find this middle point, for example, you find the slower one, you actually want to move your slope 1 step behind it, so that you can starting from the beginning and then compare the values. But that's pretty much it. I hope you guys learned something, and I will see you next time. See ya.